again, but we're introducing you to 3 new trig functions. So our objective is to understand it and use trigonometric relationships of, this should say right triangles. We're going to be looking at the acute angles of the right triangles. And then we'll also use it to determine side lengths of right triangles. Trigonometry means triangle measurement, and it originally started using right triangles, and then they discovered more applications from there. So we're actually going to be looking at applications of trig outside of right triangles, just not today. So you know the original 3 trig functions, sine, cosine, tangent, and of course we all know SOHCAHTOA. I'm not sure why they're called the inverse 3. I would call them the reciprocal 3 because the cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of the tangent. So in order to find the 6 trig function values, we need to know all 3 sides in the right triangle. So of course, if we're missing a side length in a right triangle, we use Pythagorean theorem. We've got leg squared plus leg squared equals hypotenuse squared. And when we solve that, we end up with a hypotenuse of 74. So when I set up the sine of theta, I'm going to look at the opposite over the hypotenuse. And then I would expect you to simplify your fractions, of course. So if you divide each of these by 2, we get 12/37. The cosecant is the reciprocal of sine, so this would be 37/12. Cosine of theta is adjacent over hypotenuse. So dividing both by 2, we get 35/37. And the secant is the reciprocal of cosine, so we get 37/35. And for the tangent, opposite over adjacent, I get 24/70, which gives me 12/35. And the cotangent is the reciprocal of the tangent, so we get 35/12. And at the bottom of the screen here, we just have that chart for you again, but you should already have that down. All right, next example. Again, we're missing a side length in our right triangle, so I'm going to use Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. And when we solve this, we get x equals the square root of 80. Well, we need to simplify our radicals. So the perfect square factor of 80 is 16. The square root of 16 is 4 times the square root of 5. So that is our missing leg. So when we find the sine of theta, opposite over hypotenuse, we get 4 square root of 5 over 12, and 4/12 simplifies to square root of 5 over 3. The cosecant is the reciprocal of that, so we get 3 over the square root of 5. Remember to rationalize that denominator. We multiply by that fancy form of 1, square root of 5 over square root of 5. In the numerator, we get 3 times the square root of 5. In the denominator, the square roots cancel and we're left with 5. The shortcut, if you're looking for one, without multiplying by that square root of 5 over square root of 5 every time, is that the radical moves to the numerator, and then you just drop the radical in the denominator and you're left with the whole number part. So for cosine of theta, we get adjacent over hypotenuse, which simplifies to 2/3, and the secant is the reciprocal of that. And then tangent would be opposite over adjacent, which simplifies to square root of 5 over 2. The cotangent is the reciprocal of that. So the shortcut on this, you move the square root to the numerator, and you just drop the radical sign in the denominator to rationalize it. All right, these last few slides should be some review of what we've been covering the last few days. So, we jump back to the example we were on. Use a trig function to find the value of x. So we have 2 options. We're missing the opposite and we know the hypotenuse. So that would lead us, thinking SOHCAHTOA, to use sine. But remember, the cosecant is the hypotenuse hypotenuse over opposite. So we could use the cosecant function to solve for x as well. The one problem with that is that our calculator doesn't have a cosecant button, so we would be using 1 over the sine, which doesn't make a whole lot of sense when we can just use the sine function. So I'm going to use sine of 30 equals opposite over hypotenuse. And to solve for x, we multiply both sides by 100. So 100 times the sine of 30 gives us 50. Alright, so now we've got our application problems. We're looking for the height of the Washington Monument. Again, 2 options. We're looking for the opposite. We know the adjacent, so using SOHCAHTOA, that would lead us to use tangent. But remember, the cotangent is the reciprocal of that, the adjacent over the opposite. Again, no cotangent button, so I'm going to stick with one of the 3 trig functions we already know. So the tangent of 78.3 equals opposite over adjacent, multiplying both sides by 115. We get approximately 555.314 feet. Anytime you have an application problem, make sure that you're labeling your answer. That was one thing that I did notice checking homework, was not all answers were labeled. And similarly, we have this time another opposite over hypotenuse. So I'm going to stick with my sine function. And in this case, instead of taking the inverse of 200 over 400, I know that simplifies to 1/2. So I'm going to use the sine inverse of 1/2 just to simplify my calculation in my calculator. And that is it. So there's your assignment. I will see you in class tomorrow.